Welcome to the Explorationist. In this episode, we journey to the southernmost reaches of our planet to explore the frozen continent of Antarctica. We'll uncover its geographic mysteries, delve into its unique wildlife, and traverse its icy landscapes. Along the way, we'll investigate its historical and modern boundaries, from the claims of early explorers to the treaties that govern it today. Prepare for an adventure to a place where nature reigns supreme and human footprints are few. And don't forget to stay tuned until the end, where I'll regale you with a personal tale from my own adventures in extreme environments. It's a story of frost, fortitude, and the frozen frontiers that test the limits of exploration. Antarctica is located at the southernmost part of the Earth, primarily situated around the South Pole. It is surrounded by the Southern Ocean, and it lies almost entirely within the Antarctic Circle. This vast icy continent is unique in that it is the coldest, driest, and windiest place on Earth, covered by an ice sheet that contains about 60% of the world's fresh water. Antarctica is the only continent without a native human population and is governed by international agreements, most notably the Antarctic Treaty System, which preserves the region for peaceful, scientific exploration and bans military activity. Antarctica is positioned between the Pacific, Atlantic, and Indian Oceans, making it somewhat isolated from the other continents. It is bordered by the Southern Ocean to the north and the Southern Hemisphere's open waters. Its extreme geographic location makes it both difficult to access and inhospitable for most forms of life. Despite this, it has become a center for scientific research, with numerous countries maintaining research stations on its shores, studying everything from glaciology and climatology to biology and astronomy. The continent plays a crucial role in Earth's climate system, influencing global weather patterns and ocean currents. This vast, icy continent is unique in that it is the coldest, driest, and windiest place on Earth, covered by an ice sheet that contains about 60% of the world's fresh water. The name Antarctica is derived from the Greek word Antarktikos, which means opposite to the Arctic or opposite to the north. It is a combination of the Greek prefix anti, meaning opposite, and Arctikos, referring to the Arctic, which itself comes from the Greek word for the bear, Arctos, symbolizing the constellation Ursa Major, commonly associated with the northern sky. The name reflects Antarctica's position at the southernmost part of the Earth, in contrast to the Arctic region at the northernmost point. The term Antarctica first appeared in the early 19th century, although the region was known to early explorers by various other names. It was popularized after various expeditions to the southern hemisphere helped confirm its existence as a large, icy landmass. Before the widespread use of the name Antarctica, the continent was often referred to by different terms, such as Terra Australis, a theoretical southern landmass believed to exist by ancient geographers. However, the modern name Antarctica became widely accepted as more exploration and scientific study of the continent occurred. Positioned asymmetrically around the South Pole and largely south of the Antarctic Circle, Antarctica is surrounded by the Southern Ocean. Did you know that rivers actually exist in Antarctica? The longest is the Onyx River. Antarctica covers more than 14.2 million square kilometers, about 5.5 million square miles, almost double the area of Australia, making it the fifth largest continent and comparable to the surface area of Pluto. Its coastline is almost 18,000 kilometers, or 11,200 miles, long. Of the 4 coastal types, 44% of the coast is floating ice in the form of an ice shelf. 38% consists of ice walls that rest on rock. 13% is ice streams or the edge of glaciers, and the remaining 5% is exposed rock. The lakes that lie at the base of the continental ice sheet occur mainly in the McMurdo Dry Valleys or various oases. Lake Vostok, discovered beneath Russia's Vostok Station, is the largest subglacial lake globally and one of the largest lakes in the world. During the summer, the ice at the edges of the lakes can melt and liquid moats temporarily form. Antarctica has both saline and freshwater lakes. Antarctica is divided into West Antarctica and East Antarctica by the Transantarctic Mountains, which stretch from Victoria Land to the Ross Sea. East Antarctica comprises Coates Land, Queen Maud Land, Enderby Land, Mac, Robertson Land, Wilkes Land, and Victoria Land. West Antarctica includes the Antarctic Peninsula, which is experiencing rapid warming. The Ellsworth Mountains, containing the highest peak, Vinson Massif, 4,892 meters or 16,050 feet, are also part of West Antarctica. Antarctica's extreme environment supports a surprisingly diverse array of life. In its frigid waters, krill form the base of the food chain, sustaining larger species like whales, seals, and penguins. Emperor and Adelie penguins are iconic residents, while Weddell, leopard, and craybeater seals thrive along the coasts. Migratory seabirds, including skuas and petrels, visit during the brief summer, and whales such as humpbacks and orcas frequent the surrounding ocean to feed. Vegetation is limited to hardy mosses, lichens, and algae that cling to rocky outcrops where ice retreats during summer. These modest ecosystems are a testament to life's adaptability in one of Earth's harshest climates. The first sighting of Antarctica's ice shelves occurred in 1820 during a Russian expedition led by Fabian Gottlieb von Bellingshausen and Mikhail Lazarev. Subsequent decades saw exploration by French, British, and American expeditions. The first confirmed landing occurred in 1895 by a Norwegian team. In the 20th century, British explorers Robert Falcon Scott and Ernest Shackleton ventured into the interior, while Norwegian explorer Roald Amundsen became the first to reach the geographic South Pole in 1911. Antarctica is unique in its governance. It has no indigenous population and is not claimed as sovereign territory by any single nation. Instead, it is governed by the Antarctic Treaty System, established in 1959 and enacted in 1961. This treaty designates the continent as a zone for scientific research and environmental preservation, banning military activities, mineral mining, and nuclear testing. 7 countries, Argentina, Australia, Chile, France, New Zealand, Norway, and the United Kingdom, have made territorial claims in Antarctica. These claims often overlap, particularly on the Antarctic Peninsula, leading to diplomatic complexities. However, the Antarctic Treaty prohibits new claims and effectively suspends disputes. Notably, vast areas such as Marie Byrd Land remain unclaimed. Boundaries, both natural and artificial, have been a key aspect of human history, often determining the relationships between nations, peoples, and environments. The earliest boundaries were likely those created by physical features like rivers, mountains, and seas, which naturally separated groups. Over time, humans began to formalize these boundaries, either through treaties, wars, or agreements, resulting in the political map we know today. Some boundaries, like the US-Canada border, were the result of negotiated treaties, while others, like the borders of Antarctica, were shaped by international agreements that reflect scientific and political collaboration rather than conflict. The Antarctic region presents a unique example of how boundaries are defined and regulated. In 1959, the Antarctic Treaty established the continent as a scientific preserve and prohibited any military activity, including the establishment of military bases. Territorial claims in Antarctica are suspended under the treaty, and the continent is dedicated to peaceful, cooperative research. Despite the lack of sovereignty in Antarctica, several countries maintain territorial claims, and there have been instances of tension, particularly between Argentina, Chile, and the United Kingdom over overlapping claims. These disputes highlight how even uninhabited or remote regions can still be subject to boundary-related conflicts. One of the most interesting aspects of Antarctica's boundary discussions involves its civilian inhabitants. The first permanent human presence in the region began with British and American sealers and whalers who spent years on islands like South Georgia. The population fluctuated greatly, with as many as 2,000 people residing there during the summer whaling season. However, it wasn't until the mid-20th century that scientific research stations were established, beginning with the United States Amundsen Scott Station at the South Pole. Since then, various countries have set up year-round research stations, and the population of the continent grows in summer and dwindles in winter, with roughly 4,800 people in the warmer months. Over the years, the boundaries of Antarctica have attracted not only geopolitical interest, but also scientific curiosity. The first child born in the southern polar region, Solveig Gunnbjørg Jacobsen, was born in 1913 in Grytviken, South Georgia. This milestone marked the human encroachment on a place that was once considered uninhabitable. Another fascinating fact is that the first person to be born on the Antarctic mainland was Emilio Marcos Palma, an Argentine born in 1978 at the Esperanza base. These milestones, though minor in the grand scheme of human history, underscore the symbolic and practical significance of Antarctica's boundaries. Another intriguing part of boundary history lies in the role of exploration and the individuals who help chart these remote regions. Figures like Roald Amundsen, who reached the South Pole in 1911, and Ernest Shackleton, who led expeditions in search of the polar regions, played critical roles in defining the understanding of Antarctica's geography. Their voyages contributed to the foundation of modern research stations and the establishment of the Antarctic Treaty. These explorers set the stage for a global conversation about the significance of boundaries, both physical and political. In an era where international cooperation could achieve what was once thought impossible. The peaceful exploration of a previously isolated and dangerous frontier. Scientists have studied the ozone layer in the atmosphere above Antarctica since the 1970s. In 1985, British scientists working at Halley Research Station discovered a large area of low ozone concentration over Antarctica. The ozone hole covers almost the whole continent and was at its largest in September 2006. The longest-lasting event occurred in 2020. The depletion is caused by the emission of chlorofluorocarbons and halons, which break ozone into other gases. The extreme cold conditions of Antarctica allow polar stratospheric clouds to form, acting as catalysts for chemical reactions that destroy ozone. The 1987 Montreal Protocol has restricted the emissions of ozone-depleting substances. The ozone hole above Antarctica is predicted to slowly disappear. By the 2060s, ozone levels are expected to return to 1980s values. Ozone depletion cools the stratosphere, strengthening the polar vortex and preventing the outflow of cold air near the South Pole. This cooling accelerates ice melt in peripheral areas like the Antarctic Peninsula. Interesting facts and boundaries. 1. Antarctica's ice sheet contains enough water to raise global sea levels by about 58 meters, 190 feet, if it melted completely. 2. The Antarctic Circumpolar Current, Earth's most powerful ocean current, isolates the continent climatically and biologically. 3. The Antarctic Treaty represents a landmark in international cooperation, emphasizing science and conservation over conflict. The continent experiences polar extremes, with 6 months of continuous daylight in summer and 6 months of darkness in winter. Antarctica's story is one of extremes, exploration, and cooperation. Its boundaries, both natural and geopolitical, offer a fascinating lens through which to explore the broader themes in future podcasts.
In a world where history meets mystery, where boundaries are blurred, and adventure lies just beyond the horizon, one explorer dares to uncover the stories hidden in the shadows of our maps.
Seriously? Do you talk like that all the time? In a world where history meets mystery? Who talks like that?
Yes, this is how I speak.
Thanks for staying tuned to this bonus section, where I regale you with snippets from travels and adventures of my own life.
What he means is, in a world where people use the word regale, you will hear snippets from travels and adventures of one man's life.
Okay. Anyway, join me for tales from the Explorationist, a journey into the unexpected. From frostbitten nights in the Arctic to the untold dramas of surveying uncharted lands, these are the moments that shape me and the boundaries we know today. Tales from the Explorationist, because the best stories come from the edge of the map. In my decades as a surveyor, I've faced many challenges, but few compared to the relentless cold of the Arctic and subarctic regions. My journey into this world of frost and isolation began in the winter of 1976 in Alberta. Fresh out of school, I was hired as a chainer for Chevron Geophysical, working in pre-metric days to mark points every 165 feet along seismic lines. This meant dragging an aircraft cable marked with survey flagging through snow-covered roads, seismic trails cut through the woods, and farmers' fields. Every 330 feet, we'd stop to place pin flags indicating geophone placements or source points for drillers. Evenings were spent sketching chaining reports, linear representations of seismic lines, noting features like roads, pipelines, power lines, fences, gates, wells, and homes. Though this wasn't true surveying, it laid the foundation for what was to come. An opening with the surveyor and his rodman soon changed my trajectory. I joined their team and under their guidance learned to calculate elevations, latitude, and departure or X and Y coordinates from survey notes. Despite struggling with math in high school, I found trigonometry suddenly made sense in the field. Surveying became a practical application of abstract concepts, and I was hooked. One day, I asked the surveyor if I could attempt surveying a line with another rodman. Our initial effort was slow and riddled with mistakes, but it taught me invaluable lessons. Not long after, I was promoted to surveyor. With a stadia rod in hand, I measured distances and heights until technological advancements brought laser distance meters, allowing me to work faster and more accurately over miles instead of half-mile increments. Surveying seismic lines required precision and adaptability. I used sunshots, measuring the azimuth of the sun by its altitude or time to orient our lines. Each line had to be perfectly placed. Bulldozers would clear paths miles long, often over creeks and through dense forests. It was satisfying when the dozers reached the other end, confirming my calculations were correct. Looking back, I'm less proud of the environmental impact, but at the time, it was the norm. Modern seismic methods are far less invasive, but the scars of my work still crisscross Alberta and British Columbia. My work eventually took me to the Arctic, a landscape as breathtaking as it was unforgiving. Camps were built on skids and towed across ice and tundra by bulldozers. Modular trailers house sleeping quarters, kitchens, and washrooms, all connected by propane heaters and workshops. Helicopters flew us to seismic line starting points, where we worked for miles in blinding whiteouts. Pin flags were useless in these conditions, freezing and blowing away. Instead, we filled black garbage bags with snow to mark our way, their dark color providing visibility even in blizzards. Living conditions were harsh. In some camps, we stayed in canvas-sided Nodwell vehicles heated by diesel stoves. I often woke to find my hair frozen to the wall of my tent or trailer from my breath, a bizarre and recurring experience. One particularly frigid morning near Bishoe Lake in northwest Alberta, temperatures plummeted to minus 60 degrees Fahrenheit. The propane in our tanks liquefied, rendering heaters useless. Trucks wouldn't start, the oil was like jelly, and moisture in the fuel lines froze solid. In desperation, we used Herman Nelson heaters to warm vehicles under parachutes, even directing heat at propane tanks, a risky but necessary gamble. The Arctic cold wasn't just uncomfortable, it was dangerous. Drilling crews operated rigs that used water to cool drill bits and remove cuttings. One driller's helper, working without proper safety measures, had his glove freeze to a drill pipe. When the pipe rotated, it tore some of his fingers off. We rushed him to camp and then drove 4 hours to the nearest hospital, a stark reminder of the perilous conditions. Despite these challenges, there were moments of profound satisfaction. Surveying seismic lines in the north required finding pit and mound markers left along a baseline every mile. Our project fell on the 28th baseline. These baselines were cut every 24 miles, starting at the 49th parallel, and ran east and west to the boundaries of Saskatchewan and BC. These markers, with their Roman numeral-stamped iron posts, were often buried under snow, necessitating careful digging and then sunshots to establish azimuths. Calculations were done manually, using sine and cosine tables and basic calculators. Each successful survey felt like a triumph of skill and resilience. I'll never forget leading convoys of trucks carrying camp modules to remote sites, clearing paths through forests and frozen landscapes. Camps were primitive at first, with only a mechanic and a few survey crew members to set up trailers and propane heaters. Meals were scrounged together from limited supplies until the rest of the crew arrived. One morning, I woke in my four-season sleeping bag to find my hair frozen to the wall yet again. The heaters had failed, and the cold seeped into every corner of the camp. Yet we persevered, warming trucks and propane tanks and continuing our work in the bitter cold. Looking back, I marvel at the ingenuity and determination required to operate in such environments. The Arctic and subarctic taught me respect for nature's extremes and for the explorers who braved them with even fewer resources. These experiences, though grueling, shaped my career and instilled a deep appreciation for the boundaries, both physical and metaphorical, that define our world. Thanks for listening. Please subscribe, and if you have any suggestions, I'm all ears, so drop me a note. I'm always looking for new boundaries to discover. This is the Explorationist.